Amazing. And we are recording. Okay. So, what are we going to be doing this session? So, actually, we last session we stopped at the don't use client side challenge. We did solve it. Okay, technically we did solve it, but we wanted to automate it. So I made the CTF prep number 2, and let's actually go through it quickly. Let's see. Yes, this is the blinding blue that they chose for the background color. Let's set it to gray. Yeah, that's much better. Okay, of course, from the hint we understood that client side, so most likely there is no network activity when we log in, and that was true. When we verify, I forgot to remove the breakpoint. 1 second, where did I put the breakpoint? Yeah, okay. So continue. Breakpoints, if you guys don't know, it is a way to debug your program. So the web developers are going to use a lot of JavaScript in their websites. So they would want to test that the front end JavaScript that's doing all of the processing and the basically giving the HTML and the CSS functionality on the client side. So Google, the Google Chrome, it has a feature to place a debugger, a breakpoint at any line of code that you want to check into, and then as soon as that code is triggered, to stop, and you have like very fine-tuned granular control over the program. It's a nice feature tab. It's not necessary for this, but yeah. When we went to the networks tab, okay, we saw that when we go to verify, we get the response immediately, and there is no network activity. So definitely it's not sending the password to some server and it's being checked and then we get the response back. No, something is happening locally. So we said, let's see the sources. And if we see here, this is the website, Jupyter, the challenges, Pico CTF, and whatever. And then under problem, there is this piece of code, 3781. It is for this page. It's a JavaScript code, and from the structure of it, it seems fishy because it's the verify function. So this is what verifies the password. If we go actually to the verify button itself, we see it says on click. So whenever this verify button is clicked, run the verify function. That's what's important. And this is the verify function. So we get the alert incorrect password, but of course we want to know what is the real password. And if you just look at the strings here, now it is shuffled, but we can see that, okay, there's Pico, there's CTF, there's curly braces, there's random letters and numbers, then this is definitely the flag that we're looking for. So one way is to do it manually, because you'll see that this is nothing but a substring check. It's just getting a substring from 0 to 4, because split is just an integer, 4. So from 0 to 4 is Pico. So we know this is the beginning of the flag, okay? And then you see 6 to 7, no, that's too far. This is, for example, split implicitly multiplied by 1 to multiplied by 2. So this is the second piece of the flag. And it makes sense because we've seen that the flag is always Pico, CTF, curly braces, and then something. So we can arrange this manually. And then the next section will be this one. And then this one, the 3 to 4, and then 4 to 5. So we can definitely do it manually, but Adham suggested we automate it as a practice, as a good practice on the Linux tools. Now, let's go back to the web shell, and let's try it. It will be a bit, there'll be many commands to get into, but it will be very interesting and very satisfying in the end. When you get the result, it is very satisfying. So let me actually get my password so I can log into the web shell. And I hope I do not leak my password. Okay. So far so good. Everything's clear. This is what we just did last recap of the where we stopped last time. Ali, Timothy, Jerosha, all good? You managed to do it? That's good. If it works, it works. But let's try to... okay, amazing, all good. Let's try to automate it. Let me just copy something else into my clipboard so I don't accidentally paste my password somewhere. Okay, let's zoom in. It should be good. So this is the web shell. This is just Linux, just plain Linux. They give us some tools, and that's good. So what we're going to do is there is a text editor, a CLI text editor. What does that mean? CLI just stands for command line interface, which is what we're interacting with. We're interacting with a terminal. You know, just give it text, we get text back. There is no graphics being rendered. So we cannot open VS Code here. We cannot open Notepad++ or anything. But what we can do is use editors that run inside of the terminal. One of them is Nano, and you might have also heard of Vim, which is tricky to exit, but so here you can start writing, and then to exit, you do Q, this Q and then exclamation mark. I hope it's correct. Okay, alhamdulillah, I was able to exit Vim. But yeah, we're going to use Nano. It's very simple. We're going to paste what we have into a file because we want to manipulate that text. So let's call it JS. Okay. And let me go back. I'll copy this portion because this is what interests us, because here is the flag. It's in this section. We don't care about the rest. It'll just be noise and it can get in the way. I will make one small adjustment though to make this 100 times easier. It's just one small adjustment. It's just one small manual thing. And that's here. Because you notice a pattern, right? You see here, there is a 0. Here, there is a 6. Here's a 4, 3, 5, 2. You know, these can be detected when you manipulate it. But here, it's difficult because it's the odd one out. There is no number here. So it will, if we try to read, for example, the first number in each line, here it will read 0, here 6. But here it will skip this and it will read 2. And things will get tricky. So to save ourselves a big headache, I'll just add this, and technically it's still correct code. The JavaScript code is still correct, but now it's easier to manipulate as text. So now we have the text in the Nano editor. Okay, it looks good. We should be able to start manipulating the code. So I'll do Control, and then let's see, what do I need? Oh, write out to save the file. Okay, so Control O. It tells me the file name. I'll not change it, so I'll just press Enter. Okay, wrote 8 lines, so it saved the 8 lines we just wrote. Now I can do Control X to exit. Amazing. Now if we do cat is just to read the file. Let's just make sure. Okay, beautiful. We have our text in the JS file. So everything is good. Everyone, amazing. Okay, good, amazing to hear. Okay, so now let's start the interesting stuff. Okay, there is in Bash. I'm not sure if we covered it in last session or not. Piping commands is what we really need here. Is just the simple concept of we take we take the output from one command and use it as the input to another. Instead of, like, for example, running the command and then saving the output to the file and then running the next command on that file. That's possible, but then it gets tricky, especially when we want to run many commands and we want to do many manipulations at the same time. It becomes too much. So what's the first step? The first step is we want to cat out the file. Okay, so we want to cat out the file and then we want to pipe it into the next command. So what is the methodology that we're going to follow here? So let's see. Yeah, I'm trying to understand my own command because regular expressions can get tricky. But okay, and then aside. Okay. And then okay. I'm actually surprised this command ran and it worked, but let's write it out. Okay, so grep. I believe we did it last time. It is basically a utility to find patterns in text. And we used, I think, the dash I and the dash O. So here we actually just need the dash O, and dash E is optional. Dash O is to basically return only what matches, because by default it will return the entire line that matches, which is going to be useless, because of course it's going to match in every line what we're going to do. But we wanted to just match, to return the match exactly. And okay, one second, someone is joining. Okay. So what is our beautiful regular expression? So we start with the quotation. Okay, we're gonna place our regular expression here. So we were looking for parentheses. So we want to take this piece out. So in regular expression, the parentheses, they have a meaning. Okay, so we just want the literal parentheses. So we need to escape it using a backslash. Okay, so let's actually see, let's run it every bit. So, okay, now we matched this. This makes sense because in every line there is this there is this opening parentheses, but we actually want this. So we need to fine tune, add something else. طيب, okay, we said parentheses, and then there's a special character set. What does that mean? That means just a group of characters. Instead of writing them all, there's a basically a catch-all for them. So the dash W just means give me any alphanumeric, any letter, any number, okay, for one time. So this makes sense. What did this do? This matched here, and then matched here, and then matched here, and then matched here, okay? We're getting there, but of course we need to add something else. We need actually more than one. So the star means 0 or more. Okay, so if we run this, what do we see? It matches the parentheses. Let me cut out the file one more time. So this matched the parentheses, and then it kept matching any letter or number. So it kept matching here, here, until it saw the dot. Dot is not a number or a character from A to Z in any lowercase or uppercase. So it stopped here, and the same thing here. And of course, it matched here as well, because this is a number, but it stopped at the comma. So we're getting closer, okay? We're building out the expression. Okay, now I actually want to match the literal star. Okay, so I need to escape it. I need to escape the star. So now, okay. Now I'm telling it to give me the literal star. So it matches this until here, this until here. Okay. For some reason, I wrote to match more than one star. I don't know what I was thinking of when I was writing that command, so we'll skip that part. But what I want after that is to match a digit. So a star and then a digit to get this. So let's see. A digit is just \d, just like we did \w for letters and numbers. \d is just for numbers. And we get nothing. That means my command was actually right. I do need 0 or more. Or, wow. Oh, sorry, yeah. So not just one digit. This is no, this is fine. But not just one digit. It's 0 or more digits. Yeah. So let's see. So far, okay, one second. Yeah. Okay. So far we're capturing what? We're capturing this, and this. Okay, but we still need to complete the expression. it is still missing. In a second. Yeah. Oh, I made a very interesting mistake here. No. Here, what we're saying, let's read it out to see the mistake. We want to capture this part. This part is what? Literal parentheses, we got that. And then any combination of numbers and letters, any number of those, okay, we get that. And then a literal star, we get that. And then any number of digits. This is incorrect. Now, now I get the command that I wrote 2 days ago. Okay, let's see. Why is this wrong? First of all, this will eliminate this one because this one does not have a star. So right off the bat, we lost one of the lines. So there was actually a need for this. What does this mean? This means match for me the star, okay, the star character asterisk, 0 or more times. So here it will be 1 time, okay. Here it will be 1 time, but here also included even if it's 0 times. So we want to capture this as well, not just these ones, okay? So this makes sense. And then we want to capture a digit, which is going to be this digit, okay? It's only going to be 1 digit because we know we never exceed 9. It's always maximum 8. So it depends case by case. And then we're gonna do a catch all, literally anything. Dot star, catch everything, equal signs, commas, dots, quotations, everything, until you find a closing parentheses. And okay, let's see. Is this correct? Backslash W star backslash star backslash D dot star. Frankly, I have no clue why it's not working. Let's see. And we're gonna get it to work. This is the debugging experience. Let's see. So this makes sense. Parentheses, alphanumeric, 0 or more, literal star, also 0 or more.
Omar, what does the capital E flag do?
Capital E just stands for extended regex. By default, I think there's a smaller subset of regex that you can use, and that's actually. Is it here? Let's double check it together. Yeah, extend. Patterns are extended regular expressions. So just instead of the basic regular expressions. Now the difference between the basic and extended, I'm not sure, but so it's just safer to have the extended version. So it's both the basic and the extended. Let's see. Guys, it ran on my PC, 100%. It ran on my PC.
Omar, maybe you need to escape the dot.
I want the dot. I want like the capture all. So that's why. But what if I just stop there? Wow, how is it? Oh, it's that digit. That's being okay. Oh wait. Did I? Do I really need this? Sorry. Nope. Let's cover. Is there really a difference between, because I ran this on my terminal, like I'll actually try writing the full command and see if it, okay, yeah, I need to change it. Just call JS only. Yeah, how this exact command is what I used on my computer. That is very interesting. You know what? Just to save time, I'll run it on my terminal. I don't know if there's a difference between like the Mac grep and the Linux grep. That has never happened to me before. But of course, it will happen when I'm recording. But yeah, let's see. I'll copy the same thing. And yeah, it works here. That's weird. That says
Consider trying the one in the comments. Someone wrote a regular expression in the comments. Consider trying it.
Ooh. Okay. Let's see. Okay, this is fairly close to what we're going for. I'll show you on my machine, tamam? And this can be an exercise for you guys to figure out why it was not running on the Linux machine. Let me clear this because we want to move on to the other challenges. But yeah. Okay. Yep. So okay, now you should see my terminal. Okay, so no, let me. Okay, so this is, we're just cutting out the file, read out the file. Here it's just a different name. Same grep, and then this pattern. We're looking for parentheses, and then any number of words and or numbers. And then the literal star for 0 or more times. For us, it's actually 0 or 1, but you know, just for simplicity. And then we're looking for a digit, and then anything after that until we reach parentheses. So this is what we get. Beautiful. Now, we notice, okay, we notice something. Now we have the numbers here at the beginning. Yani, it's very easy to sort by this. There is literally a utility called sort. But how would we want to sort? We want to sort by number. So if we specify -n, it will specify by the first number it meets. So here it will be by 0. So this, it will be counted as 6. So it will sort 2 first, and then 3, and then 4, and then 5, and 6, 7. That's exactly what it's going to do. It's going to sort by the first number it sees in each line. So we get this. We get 0, 2, 3, 4, 5, 6, 7. Okay. Now, basically, you have the flag, like the order of the lines. Now we just need to extract what's in the quotation, okay? So we're going to use grep again. So we're going to pipe it. So we read the file. We get this portion of the file using grep. We take the output from that. We feed it into the sort function or utility, which sorts the lines. And then we're going to feed that into another grep command, which is going to extract what's in the quotation marks. Okay, so we're going to do what? Quotations, anything, quotation. What does this mean? The outer quotation is just to encapsulate everything as like the input to the utility. And then this is the literal quotation we're looking for. And then dot star means anything. Match everything in the world, okay? So that's what we want. And then there's a utility called translate. It has many features. You can literally translate I'll give you an example. So this is the output we had. I can literally turn every P into L, for example. So see what happened? This became L. This became L as well. It's literally as simple as that. You can translate, for example, any PI into LN, anything. So now any PI becomes LN. It's as simple as that. This gets substituted into this. This gets substituted into that. Now it also has other utilities, but what we need is the delete. That's it. We want to delete. So we're going to delete what? Everything inside these quotations is what we want to delete. We want to delete the quotations. Okay. So we want to remove these quotations, and then we want to delete the \n. \n is the new line character. So we just want to make it one line input, and that's it. That is it. Oh, I think okay, that's the output. Now it's missing a curly braces from here. I don't know how I copied the file by mistake. But yeah, this is the flag. It is Pico, curly braces, no clients, please, and then this is the random number to verify the hash. That's it. And we're done with this challenge. Okay, let's move on to the next challenge. Ooh, need to start running. No, it's fine. We have time. Okay, the next one is where are the robots? Of course, the name is always 90% of the solution. Where are the robots? Okay, let's see. Simple page, where are the robots? We'll get to what it's hinting at, but let's see, maybe they're hiding something in the HTML. No, seems normal. There is some fonts that you're using, style sheets, and a very simple HTML. Is there maybe network traffic? There's no network traffic. There's no JavaScript to look at. So of course, the word robots has to have a meaning, and it has a very important meaning. So web servers, they can have, and it's advised to have a file called robots.txt. Let's see what that is. A robot.txt file tells search engine crawlers which URLs the crawler can access on your site. This is mainly used to avoid overloading your site with requests. It's not a mechanism for keeping a web page out of Google. To keep a web page, okay, whatever. That's technical stuff related to Google. It's literally a way to exclude files from being scraped by bots. Okay, so Google, how does it reach your website? How does it, for example, get this text? How does it get the title? How does it get the everything about the pages it indexes? They have many very tiny computers. Big computers running tiny browsers, web browsers, that will go all over the web, just requesting websites, just requesting everything on your website, slash dashboard, slash news, slash sports, everything. Okay. And they do it recursively and just to index the web pages. Now you can ask Google to please don't read these paths, for example, because you don't want it to keep bombarding you with requests. And also something new that came up, and you might find it when you go to the robots.txt file, is GPT bot. The GPT bot is what OpenAI use to scrape the internet. Basically, they need to collect huge amounts of data from the internet. So they go around and they request websites. And if you add to your robots.txt file that you don't want GPT bot to scrape it, it should not scrape it. Now, do they have to? No, it's more of an ethical thing. So they can or they cannot. Okay, so this says user agent. User agent is what we're accessing the website from. It could be our browser, or if you're making it from the terminal, the request from the terminal, it can be whatever utility, like curl, for example, that we used in the last workshop. So here it says all user agents, which is kind of odd, should not access 47ce.html. So what are we going to do? We're going to do the opposite of that. We're going to access 47ce. Okay, and that's it. We access the flag, because you wouldn't normally go to 47ce.html. You're not going to guess something like that. But since we went to the robots.txt file, we saw the disallowed entries. And let me actually show you what I was referring to. Let me do some. Is it here? Yes, it is here. Beautiful. Okay, so If you go to Amazon.ae or .com or whatever, and you go to /robots.txt, it's literally a text file. Now they disallow all of this weird stuff. Okay, I have no clue why or what they are. It's probably their stuff. But at the end, you'll find some interesting entries. Let me zoom in a bit. You find it interesting. So there's a user agent called Itau Spider. I don't know who uses that. And then GPT bot. They are telling it, don't touch anything. So if OpenAI actually abide by the robots.txt, then they will not scrape any data from Amazon. So that's what it's used for. What to scrape and what not to scrape. But yeah, now we get the flag. Is it the correct flag? Let's see. Let's submit the flag. And yes, beautiful. Now we can move on to the next challenge, Scavenger Hunt. Okay, is everyone following up? Everything good? One flag is missing, one part split. Okay, honestly, Ali, all I can tell you is that it worked on my machine. But yeah, I really think you guys can fix it and make it work on the web shell. And if you do, please share it with us. We can see it next session. Okay, all good. Let's see. There is some interesting information hidden around the site. Can you find it? Okay, let's see. Let's turn this off. Just some boring HTML. How do you like my website? What? I use these to make the site. HTML, of course, CSS, of course, JavaScript, of course. The most basic components you can have. Okay. What did it say? It said information hidden around the site. Okay, let's start inspecting. This is the inspect elements tools. Okay, let's see. Just some boring HTML, definitely. And then they have, oh, what's this? As we are expanding the containers of the website, so here they have a heading, some paragraph, this paragraph, and then they have this about, okay, which is not even showing up, which is weird. Like, see, when I highlight this, I'm sorry, when I highlight this, I can see what it corresponds to in the actual rendered website. But when I go to the about, ID about, it's nowhere to be found. Oh, it's the other flag. Yes. It's this one. So it tells us what it used, blah, blah, blah. And then we see a comment. The comment here is the first part of the flag. Okay, that's the first part. Let's copy the first part. So there's probably a pattern here. If you see something in the HTML, it's probably a good idea to inspect the CSS as well. And immediately we find it. It's similar to the last one we did, I think. We did one similar to it last session, but yeah, it tells you CSS makes the page look nice. That's true. And it also has part of the flag, which is convenient. Here's part 2. Okay. Now we have the second part. That's a lot, probably, I'm guessing. We go to the JS JavaScript, and it doesn't give us the third part. It says, how can I keep Google from indexing my website? Guys, how can it stop Google from indexing the website?
Robots.txt.
Exactly. Yes, robots. Exactly. Robots.txt type. Let's see. Part 3. Okay, now we have part 3. It's actually not 3 parts. I think it's 4 or 5. Yeah, I think it's 4. It says part 3. I think this is an Apache server. Can you access the flag? Yeah, there's 2 more parts. And one of them is annoying. This one is fine. But the one after this is a bit annoying. But okay, this is an Apache server. Can you access the next flag? Okay. So there are many different servers out there. One of them is Apache. I think it's the most widespread one. It's open source. It's free. And it's an HTTP server. It's going to serve, it's what's serving us this website. And if you actually go to a tool called Wapalizer, it's a very convenient tool. It is not showing up here. If I go, I think, to here. Yeah, it's not showing, but it's a tool that analyzes the website, both the front end, and if it looks for patterns, maybe in the HTTP request, maybe in the what files you're importing, and it will try to give you an overview of what the website is using. So it tells you UI frameworks is Bootstrap. It's just for CSS. And font, Google font, interesting. And then it also says PHP, a programming language that's being used. So this tells us probably it's an Apache server. Usually it can even detect it, but I guess here it's such a small website that it's not easy to detect. But we have the hint anyways. We've been told it's an Apache server. So any web server is bound to have temporary files. It's bound to have configuration files. It's bound to have all of these files. It's used to run the server, not just the files that you're going to serve, like the index.html and the CSS. No, there has to be files related to the configuration. So let's look for an Apache server word list. A word list is just a tool, okay? Sorry, it's just a list of words that you can use in fuzzing tools, and I'll explain what that is, to find these hidden directories. So fuzzing or web, what's it called? Yeah, directory searching is just you trying many different possible directories. Like, for example, /dashboard, /login, /admin. These are possible. They're not always there. So you have a word list of all of these, hundreds of these, maybe even thousands, and you try them. So we're not going to try everything. We want to be more specific because you understand it's an Apache server. So we look for an Apache word list. It will have the names of these configuration files. So as you can see, there's HTA access, HTA password, meta, web, access log. So these are log files. There is error log, HTTPD, server info. Like, let's try server info. So we go here, we go /server info. Do we get anything? Not found. That's fine. So, where is the word list? Yeah, not found. So they are very generous. And when they were creating this website, actually, you know what? Let's try to do it fully, because it is the first one. This is it is the first one. But do they have GoBuster? They have their search. Wow, they have their buster. They don't have anything. They don't have anything. We need to. I think we might need to curl this. Let's see. Let's see what we get when we try to curl this. What is the type of response we get back? This will be interesting. Okay, not found. And if we try anything else, same thing. Okay. To ask a second. Okay. Ooh, interesting. Let's see, will this actually work? Done. Oh. Okay. Let's try to automate this. Let's wget the word list. Wget is just to download. As simple as that. We're going to download the word list. Beautiful. Now, if we list the directory, we find apache.txt. Let's cat that. That is definitely not what we need. That is the whole request. Wait. What if I curl? Okay, we're getting, okay. I think I need to get the row. Yes. So row basically gives you the exact file without the actual GitHub website around it. So let's try curling this. Beautiful. Okay. So what do we have now? We have this URL, which is the raw version, which is the exact file. No GitHub, no nothing around it. So we can curl it, and then we can put it into a file. That's it. We're gonna call it wordlist.txt. Okay. And now, okay, let me double check. It is actually. Oh yeah, yep. We don't have root access. Yeah. That's sad. Okay, interesting. Let's trust that this code works from ChatGPT. And okay, we're gonna call this dir.sh. So I'm just opening the text editor, the nano text editor, and ChatGPT gave us this beautiful piece of text because honestly, I barely write any bash. So what is the base URL? It is going to be this. It's going to be this. And then the word list.txt, I think we called it Apache, or we'll figure it out. Okay, and then here, all it's doing is a while loop to go over all the entries in the text file we have, the word list file, and then it will just say we're trying this path, and then it will give us the output. And then it will print a new line just for readability, that's it. And then this is done. When it finishes this is the syntax for a while loop in Bash. You need to do while, do, done. And here we're feeding it the word list, which is wordlist.txt. So it's simple. The concept is simple. All that we're doing is we're running this word list on all every entry. Sorry, we're trying to access it, and we see the response. It's not doing any validation. Did we get is it valid or not valid? We don't know. We're gonna do it manually, but okay. This is a shell, a bash script. Okay, how do we run it? We do // and then the script itself. Here we cannot do this. Why? Permission denied. Now permissions. What do we see here? Where is the permissions? Now, without going too much into details, any file has 3 types of permissions: reading, writing, executing. Okay, and it has it for 3 different people. That's why you see it repeated. The first group is the owner of the file, and then the group of the file, and then the last one is everyone else. And this is what we care about, those 3 letters, everyone else. It doesn't matter actually, because we're owner of the file anyway, so we have the most authority on the file. So we want to add execution. So we do chmod, it's a tool, plus X. That means add the execution permission to the file dir.sh. Now if we run this again, now everyone can run. Me, my group, the user group, and everyone else. So now if we do /dir, it will even auto-complete it for you. Amazing. Oh, interesting. So it ran. And we found in the .hta access, oops, I think over there, it found something. which was actually the first entry. It found, okay, blah, blah, blah. I love making websites on my Mac. I can store a lot of information there. Okay, so we have part 4. Let's write that down. And now we need just the last part. But basically what this does is just tried every word in the word list, every path. .hta, HTTP, password, meta, web, access log, blah, 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 blah. Then index.html. Of course, we know that this will give a valid response because we were on the response, the HTML, index.html, and we did get the first part of the flag. So this, okay. The most important one is the first one, which is .ht access, and give us the fourth part. Now this one is the most annoying one. So Mac likes to create temporary files. Okay, you would need to research like Mac temporary files. Okay, it will tell you go to library caches. Okay, but there's one specific type of file that you might even find a lot when people upload their entire directory on Google Drive, for example. They want to upload an entire directory, you'll find these weird dot files. They're supposed to be hidden, but when you copy everything, it gets in the way. So there's a file called DS store. Yep, Mac DS store. It's a file that stores custom attributes of its containing folder, such as folder view options, icon positions. So, you know, when you want to save, okay, this file, I want to view it as boxes, but this one I want to view it as a list. Order by date in this directory, but order by name in that directory. So this is the type of information that is stored in the DS store file. And this is the exact name of the file. You could come across this in one of the word lists, but it's highly unlikely because this file would never store any important information. So here they just want you to learn about temporary files, okay? That you should even scan even for the most useless ones because you never know what's in there. And that's a good point. So yeah, that's it. Now we have the last part of the flag. We have all 5 parts, and that's a lot of places, yeah, to look for. Yeah, exactly. Was this space there? I don't think it was there. Should not be there. Oops. Okay. Thank you, Siri. That was very unneeded. Okay. So let's submit the flag. The flag is incorrect. That means, was there a space here? Oh yeah, sorry. I added 2 extra spaces. That's my bad. That's the correct flag. Beautiful. We saw the challenge. Okay, so yes, Ahmed, go ahead.
Thank you, Amar. Now you just went straight away to the .ds store file. How would we know, like, if we had no clue that we need to
Honestly,
target?
this file is usually not even important. I'll be honest with you. But let's see if it's available in, what was it called? Yeah, sec lists. Right. So there's a very famous collection of word lists. They are called sec lists. And they are for everything from APIs to passwords to usernames, web shells, it's everything. So discovery is what we're doing now. We're discovering. Maybe it's in file system. Nope. The usual one you would use from this is web content. Web content, and then URLs. Was it URLs or I believe so. Yeah, see, it has everything. Copyright.txt, authorized.php, files.txt include, and it has so many entries. Will you find a DS store here? Honestly, it's highly unlikely. And here you have WordPress, WP admin, of course, readme.html, index.php, license, even the license files. You might actually come across the DS store, but honestly, I've never seen like a vulnerable box that utilized that. But it's an interesting thing to know. It's more of the, yeah, this is the most famous one. This will be too big. I don't think it will even load. Or okay, this has 220,000 entries. Will we find the what's it called? DS store here. It's searching. I don't think so. Yeah, it's that rare and that not super useful, to be honest. But an interesting discovery nonetheless. Maybe you'll find it in the big. I'm not sure. Yeah, it's too big to read. But okay, let's try to squeeze in one more challenge. I think this one is a simple one. The login challenge. My dog sister's brother made this website, but I can't get in. Can you help? Okay. Let's see. Before inspecting, let's try to log in. Admin, incorrect password. Okay, this seems fishy anyways. How would it be that fast? Let's see, when we do a submit a request, we don't even get any network requests. So nothing is being sent, received. So that's fishy. Let's look at the page source. We see the entire HTML. Very simple. Username, password, okay. There is an index.js. We should definitely check that out. Let's see. Oh, yes, that one. Okay, let's view it here so it's more readable. So there's a style.css, nothing fancy here. But then there is this, the index.js. Now, if we go to the button, we see it's a form, okay, that does a post method. And here under sources, it's listening here. This is the important part. It's selecting a form element, which is this form element, and it's adding a listener. So as soon as the submit is done, when I do this button, it will do the following. It will get the username and password, which I input here. And then it's doing some interesting stuff. Okay, sorry. It's going over, okay, there's an interesting function here, B to A, whatever that is. Document.query selector, value, replace, is doing some regular expressions. But then this is the important part. Return something, if the username is not equal to this, then say incorrect username. Okay, let's see. Otherwise, you're going to input this. Now, probably some of you have seen this sort of string somewhere, okay? And we'll get into that later. But, and then it's checking if the password is equal to that or not. If it's not, then it's an incorrect password. Otherwise, it is the correct password, and your flag is A to B of T.P. Now, this is confusing, but let's see what is the A to B and B to A in JavaScript. Yeah, what are these? Decodes a string of data which has been encoded using base 64 encoding. Okay, so it's an encoding function. Encoding is just think of it as a translation from one language to another. Nothing is lost, no data is hidden, but just different representation. That's it. So, okay, now we know it has to do with base 64. طيب, let's see what does the string look like. So there is a very, very famous tool called CyberChef, and it detects for you. It does so many cool things. Okay, so here it's too short, it doesn't detect it, but we know it's base 64. So yeah, here, it looks similar to this. Okay, let's try to from base 64. Okay, admin, interesting. So it's checking if the username is admin or not. So if we were to put anything, incorrect username, let's see, maybe if we put admin, incorrect password. So we passed the username. Username is good, password is incorrect because it's any garbage that I put in. Okay, now it's now going to match the password against this, which definitely looks like a base 64 string. Even if you now give it to, like, let's restart. Yeah, definitely. This magic is basically it will run some algorithms to detect if it looks similar to something. So it does it for you. CyberChef notices the patterns, okay, and it's telling you, I think this is base 64. If you do from base 64, it will give you this, which looks like human readable text, which is Pico CTF server. Okay, and this was the password. So the password is the flag. If we actually go submit this as the password, we get correct password. Your flag is this. Of course, we don't need to do that because we already know the password, the flag, because that's the password. But yeah, that's it. It gets into the main thing to learn from this challenge is encoding. And encoding is not encryption. You may have heard of encryption and you may have heard of hashing. Those are three different terms, totally different technologies and algorithms that produce them. So here, what they're doing is encoding. Encoding does not hide the data in any way. If you have access to the encoded data, you have access to the original data. There is nothing to hide. There is no key. There is no password to unlock the data. It's just a different representation. Like when you take the English text, translate it to French, it does not lose content, basically. So that's the whole point of it. Why is it used? It's used a lot in web in order to you know how we can have, for example, dots and commas, which can cause issues when you're sending the data over the HTTP, and let's say and sign and the star sign and so on. So all of this, if you encode it, it's to base 64, not from. Let's give it these symbols. See, they are now all alphabet, and there is a equal. This is for padding. So the main thing here is that now it's constrained and it's simplified and it's easy to share over the web. You won't have errors when you're decoding and when you get into servers. So it's just a simple encoding, and this is the whole idea of the password. The password is just an encoding. They want to teach you that encoding is not a way to store passwords or any sensitive data. And of course, you should never even have it on the client side. That's a different disaster to deal with. But that is basically it. Now, yeah, we solved a good number of challenges. I think we have log on. Now, there's log in and log on. We just did log in. There is log on. Now we're gonna leave it as a homework. I think this one is very interesting. It has to do with actually sending to the backend. I think it deals with databases and so on. So that's interesting. If you'd like to give it a try, that would be amazing. If not, we'll do it next week, inshallah. I hope you enjoyed and benefited. And yeah, we're going to take a 10-minute, thank you so much. We're going to take a 10-minute break, and then we'll start with the second session. Adham has the OSCP now. Inshallah, he does well. He should have started, I think, 5 minutes ago. So I'll be giving that session as well. It's going to be a try hack me box, simpler than hack the box, but inshallah, interesting nonetheless. And yeah, see you at 11:15, inshallah. Let me